Today we are going to discuss the properties of determinants. Okay. First, if any two rows or any two columns in a matrix are identical, then the determinant is 0. That is, if any two parallel lines in a matrix are identical, any two rows or any two columns, if they are identical, the determinant will vanish. If any two parallel lines in a determinant are same, then the determinant is 0. There is another case when the determinant vanishes, that is when every element in a row, in any of the row, if each element is 0, then again the determinant vanishes. If all elements in any row or column are 0, then determinant is 0. Okay, so third property is if any two parallel lines, that is any two rows or between any two columns. Okay, if any two parallel lines in a determinant is switched, then the determinant will be changing its sign. Determinant will be changing its sign. A minus sign will be introduced. That is, if you are interchanging the positions of any two rows, say this is a matrix with 3 rows, then if you are interchanging the positions of two rows, say you switch the position between R1 and R3, R1 is brought to R3 and R3 is taken to R1's position. If this is the case, the determinant will change its sign. Also, the same is true for switching the position between columns. Okay, so this is the third property. Now the next property is if you are interchanging the rows and columns of a matrix, that is, if you are taking the transpose of a matrix, then the determinant will remain unchanged. Okay, the determinant value for a matrix and its transpose will be the same if you are interchanging the positions of, if you are interchanging between the rows and columns, that is, each row is converted to each column. First row becomes first column, first row becomes first column, second row becomes second column, third row becomes third column. If this is the case, we say we have taken the transpose of the matrix. So the determinant of a matrix and its transpose are the same. Now the next property is if we are adding one row with another row or a multiple of another row. Okay, say row 2 is multiplied with a constant k, that means each element will be multiplied with this k. Okay, and we are adding this row with another row, let it be R1, or otherwise let one column be added with another column. In both these cases, the determinant is unchanged. That means if we are adding between any two parallel lines, then the determinant will be unchanged. Next property is if some or all the elements of a row or column in a determinant are expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two determinants. Okay, so consider example. If you have a determinant given like this, that is, each element is multiplied, is expressed as a sum. If each element in a row is expressed as a sum, then the determinant can also be expressed as the sum of two determinants. Okay. plus the determinant given by this is property number 6. If and the next property is if each element in a determinant is multiplied by a constant, then the determinant can also be expressed as a product of that constant and the original determinant. Let delta be the determinant of the original matrix without k. If the determinant of this matrix is delta, then the determinant of the matrix with each element in a row multiplied with the constant can be expressed as k into delta. Okay. If each element in a row or column is multiplied with the constant, then the determinant will also get multiplied with the same constant. In other words, if you are given with a determinant where all the element in a row is multiplied by a particular factor, then you can take that common factor out and then calculate the simplified determinant and then multiply it with the common factor taken out. Okay, this property can be used for simplification. In any row or column, you can always take out the common factors out and thereby make the calculation simpler and then multiply the determinant obtained with the common factors that you have taken out.